In this section, we're going to cover hypothesis testing still for the mean, but when sigma is unknown. And just like with chapter 6, what we're going to see here is that when sigma is unknown, we're not going to use a normal distribution. We're going to use that t distribution instead here. So again, in the previous section, we dealt with sigma, where that's the population standard deviation being known. This is not always the case though. So if you're doing new research, there's not a lot of research already done on that population, or maybe it's very old research and you're not sure if the values are still relevant, then you may not know the population standard deviation. So in that case, we cannot use the normal distribution. We use another bell-shaped distribution called the t distribution instead. And this is very similar to what we did in chapter 6. So you're going to see a lot of the same procedures here as the beginning part of chapter 7, but instead of using z values, we're going to use those t values instead. And I'm going to start this lesson here focusing on the critical value method first. We just kind of wrapped up those videos, so hopefully it's fresh in your mind. So we're going to start with the critical value method first for those t distributions, and then we'll go to the p-value method for the t distributions as well, because you can use, again, either method here. Very, very similar to the first couple chapters in 7. So to find the critical value for a t distribution, first of all, you are going to figure out what your alpha is. And here it's a little different. Don't forget, you have to identify your degrees of freedom. So that's the sample size -1. Now, you can use table 5 in the back of your book to find these critical values. And honestly, we can use technology here. You can do it using inverse T, but the table is actually easier. So this is one of those rare times where normally, if you haven't noticed by now, I'm very use technology. It makes your life much easier and faster. But this is one of those rare cases where the table for table 5 is rather quick and easy to use. And it's not as much dependent on where the shading is. So it kind of gives you all 3 options in the table. So you don't have to subtract with 1 or anything like that. It's really nice. So I do actually recommend the table for this section, although I will briefly show you how you can use technology if you're interested. Now, as we go through the table, if you have a left tail test, you're going to see that there are different columns or different highlights. One will say 1 tail, one will say 2 tails. So if it's a left tail test, you're going to use the 1 tail value, but just put a negative sign there. If it's a right tail test, you're going to use the 1 tail value with a positive sign. And if you have a 2 tail test, you're going to use the 2 tail section and have a negative and a positive sign. So you have 2 answers just like before. So let's go ahead and practice doing these. And actually the pictures look very similar to the last section. So I'll draw the pictures here in the examples, but if you want to see the general pictures, you can check out your text. So find the critical value t sub 0 for a left tail test with alpha at 0.05 and n equals 21. So I'll draw the pictures here. So a distribution, a t distribution is still a bell-shaped curve, and it still has its center at 0. So that kind of makes it nice. It starts very similar. You have a left tail test, so that entire alpha is going to be in that left tail. And you're looking for that, in this case, it's going to be a negative value, right? Because it's on the left of 0. So we're looking for that value here. Now, let me bring up the T table. Sorry, I have so many tables here. We got to bring this over. So I'm bringing over my T distribution table here. So notice I have a left tail test. So I'm only in 1 tail, right? It's just the left tail, not both. So I'm going to use the 1 tail section, and I'm going to use the negative sign with it. And keep in mind here, my n is 21. So my degrees of freedom is going to be n minus 1, which is 21 minus 1, which is 20. So I'm using, I'm going to scale up just a little bit here. The degrees of freedom for 20, so right here, right? But we want to keep in mind that we're going to use, see how you have level of confidence, 1 tail, 2 tail. So in the chapter 6 stuff, we use level of confidence. Here, you're going to use one of the others. I'm going to use 1 tail because my alpha is in just 1 tail. And you can actually see the pictures here, right? My alpha looks like this. So I'm going to use the 1 tail. My alpha value was 0.05. So one tail, there's the 0.05. And then I'm going to go down to the correct degrees of freedom, which is 20 here. So I see 1.725. So I'm going to use that value. Again, there's my degrees of freedom, and then I'm in the one tail 0.05 section. So when I go down, I get that value here. And for a left test, just a reminder, you're going to use a negative, right? Because you get a negative value there. So we're looking at negative 1.725. So that's it. We're done. The table is pretty quick. If you're using the calculator, you would use second vars, then inverse t, and you do have to give the area to the left, and then you have to give the degrees of freedom. So here, the area to the left of this t value is just 0.05. The left tail tests are pretty easy. So 0.05, and our degrees of freedom here is 20. And you can see I get about negative 1.7247, which if I round to 3 decimal places does match the value that I got here. So you can do it on the calculator. They both work. So I'll show you how to do it both ways as you go through. All right. Find the critical value for a right tail test. So I'm going to do one of each. Alpha is 0.01 here and n is 17. So again, I'm always going to start with a picture. So that's a bad bell curve, but you guys get the idea. So right tail test, so my value is somewhere over here. And that whole alpha is going on this right tail, right? It's going to keep going. So that whole alpha of 0.01 is going on the right tail. So let's do the calculator first because it's kind of fresh in our mind. So I'm going to do second vars inverse t. Now you just need to be careful. It's area to the left. Always, always, always to the left when you use those inverse functions. So if you think about it, if I want the area to the left, it's going to be 1 minus the 0.01. So you're looking at 0.99 here for your area to the left. And my degrees of freedom is going to be 16 in this case, 17 minus 1. All right, and I'm getting about 2.583487, so about 2.583 if I round to 3 decimal places. All right, let's see what we get using the formula. Or not the formula, sorry, the table. So keep in mind, it's only in one tail. So I'm going to use the one tail section, and the area in one tail is 0.01. So here, again, I'm looking at the one tail, and the area I want is 0.01. Just be careful, it's not 0.10, 0.01. And my degrees of freedom, we said, was 16. So if I go down to 16, I see there's that same 2.583 value I just had. All right, and let's do one more. So let's find the critical values for a two-tail test now. And again, I'm drawing a picture every time. If you can do it without the picture, that's okay. I just caution you to be really careful that you understand what's going on. I think the picture always helps. So if I have two tails, that means both of these sides are colored in, and you just need to be careful because that alpha has to get split in half, right? Half goes in each tail. So 0.10 divided by 2 is 0.05. So you have 0.05 over here, so half of it, and the other half over here. Now, if you want to do your calculator, we're using inverse t. So I'm going to do this one first. The area to the left is pretty easy. It's 0.05. And my degrees of freedom is going to be 25 here. And then if I do the other one, I'm looking at inverse t. And again, just be careful. If I want the area to the left, it's going to be 1 minus the area on the right. So I'm doing 0.95, comma, 25. So let's see. Now, again, this is symmetric, so I really don't need to do both sides. But if you're a little unsure of yourself, it doesn't hurt to do both. I'm just going to round to 3 decimal places here, negative 1.708, because it does do that check for you. So if you're not really sure if you're doing this right, do both sides. You should get the same answer, but one positive, one negative. But if you just do one side, that's okay too. You just take both signs. So there are our 2 critical values. Now for the table, bring that over one more time here. So here you just want to be careful. We are using 2 tails now, right? It's a 2-tail test. So the amount in 2 tails was 0.10. So you're doing the total alpha in the original 2 tails. And our, degrees of freedom was 25. So if you go down here, you see that it does match with that 1.7. You see that 1.708. So if you have 2 tails, then you just take the 1.708 on a positive, and then you take the negative 1.708 as well. So this table always gives you the positive answer. So sometimes you may have to take the negative instead if you have 2 tails or if you have a left-tailed. So those will be our critical values there. Now, what we're going to do next, and I'll pause this video and start the next video, is go through the full hypothesis testing again using these t-values here. So we're using the same formula really that we did in the last section. The only difference is instead of using sigma, we're going to use S, which is the sample mean, the sample standard deviation, sorry. So it's the same basic formula, but you're just using the sample standard deviation instead. We're still thinking about, in this case, those critical values. So instead of being Z values, they're going to be T values, but that similar procedure is going to be there. So the procedure is really not going to change. It's just that instead of everything being Z, you're referring to T values instead, but the same process is going to exist. One final note before we go on is that obviously table 5, where it has those t values, is not perfect, so it doesn't have every value in the world. So what you do want to do is use the closest number in the table that is less than the value you need if it's not given, or use technology. So let's say your degrees of freedom was 57, but 57 is not giving in the table. You use the smallest, the closest value that's smaller than it. So 50 would be the closest value that's smaller, so you would use that value instead. Or you can go ahead and use the inverse t piece that we were just doing. So just keep that in mind. I would think most of your questions on the homework, it will be there, but you can either use technology if they're not, or just use the next value down for the degrees of freedom.